Hello everyone, in this video we're going to explore topic 8.13, the arc length of a smooth planar curve and distance traveled. Alright, definition of arc length. Let the function given by y equals f(s) represent a smooth curve on the interval a and b. The arc length of the function f between a and b is given by this formula. Similarly, for a smooth curve given by s equals g of y, the arc length of the function g between c and d is given by this formula. Alright, now again, we have the point on the line s1, y1 and s2, y2. Alright, the distance from here to here is given by the formula d equals square root of s2 minus s1 square plus y2 minus y1 altogether square, right? Which is you already learned in geometry. Now we're going to use calculus to prove this formula. So how do we do it? Now we're going to start by saying f prime of s. This guy actually the slope of the tangent line, right? It's going to be given by the formula y2 minus y1 over s2 minus s1, right? And this one is the change in y divided by change in s, or rise over run, right? Now if I square both sides, so what happens? So I have f prime of s all together square. It's gonna be y2 minus y1 over s2 minus s1 all together square, right? Now the left endpoint has the coordinate s1, right? The right endpoint has the coordinate s2, right? So by the arc length formula right here, right, we have arc length equals the integral from s1 to s2, right? Square root of 1 plus f prime of s squared, right? The formula right here say that. So it could be y2 minus y1 over s2 minus s1 all together square. Alright. Now, number 1 right here can be written as s2 minus s1 over s2 minus s1 all together square, right? And I'm gonna rewrite every single thing else, right? Now since this guy and this guy have the same denominator, which is s2 minus s1 square, right? So I just rewrite this one in the same denominator, right? Now keep in mind the whole thing right here actually a constant, right? Because given right here, it's not variable. Variable right here is just s right here. This one is constant, this one is constant, this one is constant. So keep that in mind, right? Now, so when you take entire derivative of this one, actually you have this one right here multiplied by s, right? S is a variable, this one is constant, right? Remember, for example, if you take entire derivative of 3 ds, it's actually 3s plus c, right? So this one is exactly the same thing, right? So I just copy this one down, evaluate it from s1 to s2, right? And then does that mean you have square root of s2 minus s1 all together square plus y2 minus y1 all together square over s2 minus s1, right? Now you substitute s2 for s, it will be s2, right? And the bottom one right here, subtract s1, right? Substitute s1 for s, you get s1 right here. Now this guy and this guy right here cancel out. That's why you only have this one left. And this one actually the distance formula. We're done, right? Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as as the chemicals they take us higher. The night's young, it has just begun, as she puts her hand in mine.